So, for some reason, this has started to crash. Not just fail, but it's actually segfolding. And I have no idea why. I wanted to reproduce it locally, but I couldn't. I don't know why. Let's have another look at it. So it's only failing on Ruby 2.4.6. It's the same patch level. 2.4.6 patch level 354. And everything works. So why is it broken on Travis? I have no idea. Travis just being Travis. So there is this gem called rspec-files, which is used for detecting leaks. Why is this so complicated? I just got dual screens and I can never get these tiling things to work. There we go. So I've modified this slightly because I've been trying to figure out if I can just avoid the GC. So what's happening is it's crashing inside the GC. You can see that part of the backtrace. GC start is being called. Actually, it's not in here at the moment because I've actually changed it already. So basically it was just calling gc.start and that was crashing in Travis and I have no idea why. And the reason why it calls gc.start is because this function called current IOs is supposed to return a list of all IOs which are still within reach of the program. So what I mean by that is when you run your program and you open a file, if that file goes out of scope and you didn't close it, that's a leak. You're leaking an IO, and so we want to avoid that. And to avoid that, before we run your rspec test, we get a list of all the current IOs, and after we finish running your spec, we get a list of all IOs, and if they're not the same, then something is leaked, basically. So the reason why we need to call gc.start is because if the user has created an IO and it's gone out of scope and it's going to be closed, calling gc.start will free it. Hi, Kiki. Trying to come in? So in Ruby, there is a feature called auto close, which means when a file descriptor is garbage collected, it will automatically close it. And the problem with that, hold on a moment. The problem with that is it's not very clean if you're just leaking your IOs without closing them, if you're just expecting the garbage collector to clean up after you. I mean, I guess you could argue that's okay, but it always seems like a good practice to either use a block which closes the IO at the end of the block, or just to explicitly manage the IO correctly. And so this is part of an automatic wrapper that goes on your specs, which basically ensures that you don't leak IOs. So removing gc.start means that essentially hi Keiki. No, I'm streaming some code. No? What do you want, Keiki? No, because it's noisy. Is it okay to close the door? No, because it's a bit too noisy. No, I don't want it. Yeah. Because I didn't know. I'll open it later, okay? Right, I don't even know where I was. Auto close. So, if we don't call gc.start, then we might need to ignore IOs which are going to be automatically closed when the GC runs, but that's a little bit frustrating because it turns out a whole bunch of IOs are just auto-closed by default. I don't know how many, like, I mean, so when that goes out of scope, it will be automatically closed. What about file? See, I guess in this situation it's a little bit tricky. The main point is that if all of Ruby IOs auto-close, then we can't really force users of async to manage the IOs correctly. By correctly, I mean closing it explicitly. And so if we can't call gc.start because it crashes 2.5, I don't know, like it just seems like we should figure out why it's crashing, but if I can't reproduce it, it's kind of a pain. st4h, I think that is hash tables. I wonder if anyone else has had this problem before. gc start internal. Let's have a look at the Ruby source code and see if we can see anything that sticks out there. I think what's happening is it's a use after free bug, but I don't know why it's happening. Alright. I honestly don't think we're going to find anything. What is the branch called? What is st_4h? Traverse all the entries in the table calling function with the current entry key value 0. Oh, okay. Okay, so what is GC max rest? GC max rest. Interesting. Well, it didn't help a whole lot. There's really two options to fix it in this code. The first one is to allow auto close. I don't really like that solution very much because to me, calling close explicitly is just good code, and auto close is kind of, it makes sense in a GC language, but man, it doesn't feel that good. Doesn't really seem like a great option. So the whole point of this was to try and enforce that, but I wonder if there's just some weird issue in Travis. Let's try trashing the cache. Doesn't really make sense that would fix the issue, but maybe. I wonder if it crashes on 2.4.5. If it's just an issue that's come with the latest version of oh, come on. I love it when I just end up with Travis is just broken for some reason, and I end up making about 50 commits to try and fix it. And then I just letting it squashing everything. But testing Travis is just a nightmare when it doesn't work properly. It just causes an endless stream of commit garbage. It's super weird it crashed in 2.4.5 as well on Travis. It doesn't crash in 2.3 or 2.5. The hell's wrong with 2.4? Oh, goodness. Let's just try 2.4.0. love branch protection, except when except when I want to force push. Oh man, I probably shouldn't do that. The really weird thing is, it was working on 2.4 like 2 months ago on Travis. Let's just try redoing that and see if it works anymore. Maybe something is broken on Travis, I don't know. Alright, so it worked in 2.4.0. I wonder if it's another gem that's been updated in the meantime and has broken a bunch of stuff on 2.4. Let's have a look at what gems were actually installed and what version they were in. So that was the last successful run. And what has changed? Yeah, see it. That was working, now it's crashing. Nothing I've done has really changed. I mean, I guess some of my gems have been updated, but... So rake is the same, AST is the same, console is the same, time is the same. NOFR has changed. Ruby Prof. That's changed. And that does weird stuff. That could possibly be an issue. Let's try pinning it. Zero point 18.0. Let's just make a full list of stuff that's changed. Protocol HTTP. You know what? Let's just write a program to do it. It'll be faster than and less error prone. Ruby. Split on white space. Hold on. Let's we're gonna make array and just turn it into a hash. What am I thinking? It's not an IO. Let's just print it out and see if I actually got what I wanted. Whoops. Okay, there we go. Okay, and we just want to make a diff. So because they're already hash tables, that should be pretty straightforward. We'll just go through all the things that have failed, and we just ignore it. If that will tell us all the differences in theory. Okay, so let's pin all of those. Okay, there we go. Let's take all of that, and by a process of elimination, maybe we can figure this out. I think this is like one of those things that you shouldn't do in your own home. Seems like a fairly roundabout way to solve this issue, but I don't really know what the alternative is. I don't even know if this is gonna. And I guess in theory, like if this is gonna work, I should be able to reproduce the crash locally now. In theory, in theory, that should be the exact version of gems when Travis last passed. I still have my own Ruby prof. Come on, crash. Or don't crash. Actually, yeah, it shouldn't have crashed because I installed the gems when it was successful. And actually doesn't make sense because even with updated gems it still doesn't crash on my computer, so... But let's see if that fixes on Travis. I still don't know why Travis is failing. It just doesn't make sense. Why can I not reproduce it locally? 67394. Oh, that was when they were still using Subversion. Or not? What revision? 67. 67394. Yeah, it's identical. We need to... I don't really care about that one anymore. So it didn't crash. Okay, there we go. So what gem is causing it to crash? I have my eye on Ruby Prof. But I guess it could be anything. I'm just going to stick it on a new gem. It's such a mess on master. Okay, so this time Travis is running. The only gem we've pinned is RubyProf to 0.18.0. Surprisingly large amount of open source dev work ends up just being general maintenance like this, like bashing your head against a wall. Why is something not working? Especially as the tooling has expanded a lot. I mean, Travis is really amazing. It revolutionized the way that I built software. I have a ton of stuff on Travis, and GitHub Actions make me really excited because it just seems like the next step, like next evolution of. And Travis is kind of constrained by they've kind of their images just took a long time to be updated, and it meant that things were super complicated, especially if you wanted to use like the latest tool chains, especially with like C++ code. It's still really bad. Having access to like C++ 17, for example, is a bit of a nightmare. Okay, so let's have a look. So this is 246 with RubyProf pinned to 0.18.0. I feel like RubyProf. I mean, what else has native extensions that's changed? Message pack. Okay, it looks like it's RubyProf. Let's just confirm that. Oh, where's RubyProf? Why can I not see it here? Oh, there we go. Yeah, 0.18.0. So let's relax that. So we'll just relax that version. Let's push it. And I guess in theory, if we've identified the problem, it should break this time. Man, Cinnamon is just annoying with multiple screens. I don't know why. Maybe I just don't know how to use computers anymore. The tiling window manager is great with a single display. With two monitors, it just tries to tile it, and your cursor moves onto the other display, and it just doesn't get the tiling. The cursor is not in the right region to tile it in that bottom corner. So this should blow up. And then I guess we need to file a bug on the RubyProf repository. What has changed between what could cause the C API to self-destruct? How do I see a diff? The screen has been flickering a fair bit as well. I'm in the underground Paris on my phone. I can't see anything. I'll watch the replay for sure. Colby, are you still watching? Sorry, I should probably pay more attention to the chat. Colby just mentioned there's actually one other person who said, I can't see anything, and Colby just said, it's flickering. Yeah, I don't know, I just bought it. Today, like I haven't upgraded my computer for literally like probably 7 years, and the other day I tried to boot into Windows, and the BIOS told me your hard drive is failing. It's like the first time Smart Status has ever actually told me anything before the hardware is just completely self-destructed. So I was really impressed, actually. So the hard drive was blowing up, and I thought, okay, well, I better fix that. And then I was like, I wanted to do some live streaming. And I found, last time I tried to do this, it was a real nightmare because the software just wasn't good. And I found this amazing tool called OBS. I'll show it because it's pretty awesome. You're going to get the mirror effect. But it's just this screen capture tool, which all I can say is for free Linux software that has a GUI, it's amazing. I'm completely blown away by the quality of this tool. Firstly, you can put as many sources as you want, so you can pull from your X server. I got a webcam, and I fed that into it as well. You can add more stuff. The audio mixer is really capable. You can throw like whatever number of audio devices you want in there and stream them, mix them together however you want. I guess you can even do like multiple audio streams. Like if you had translations, like simultaneous translations or something, you could do that really easily. And then it's fully capable. Like it just has everything you could ever want. Full control. I'm using NV encode, so it's actually encoding the stream on my GPU, which is why I had to go and buy a new GPU because. Like I said, I haven't upgraded my computer for 8 years. I haven't touched anything. There was so much dust in it. I don't think I've even cleaned it out properly for at least a couple of years. And I had a GTX 770, which literally is 4 generations, each generation being 2 years in NVIDIA time. And I was trying to stream 4K, and it was just like, your GPU is not working. You're dropping too many frames, or it actually didn't even say that. It just basically said your GPU is hot enough to cook eggs. So yeah, I was really impressed. This software is free and it's just amazing. And so that's why I'm live streaming today, is because last time I tried to do this, I tried to look for the same software on my Mac laptop, and I couldn't. There was some software that kind of did it, but it was pretty crap. And on Linux there was just nothing. It was this. The best I could find was stitching together FFmpeg commands with a whole bunch of esoterics. It just was so complicated and nothing worked. So that software is amazing. I'm super impressed. Anyway, look, did it pass or fail? It should have blown up because we. Yeah, so it failed. So it's definitely RubyProf that is dying. So what changed? How do I diff between two tags? Diff between two tags on GitHub. Why is this complicated? Compare changes. To get the compare view, append/compare to your repository's path. That's intuitive. Awesome. I don't know why that's so complicated. Why do I have to manually type something into the address bar? Anyway. Yes, my base branch is master, and I want to compare. I want a tag. I want to compare the current master with. What was the tag called? 0.18.0. It's literally 0.18.0. Oh yeah, 180 commits. Assume Ruby 2.4 and higher. Bugged call stack profile outfit. Let's just make an issue. They can sort it out or close it if they care. I think we can fix this in my code by just basically pinning it to 0.18.0. Okay. Segfault when running. That's the weird thing. I'm not even using RubyProf except previous. I guess it's running previously. The spec that's failing is the one that's running after RubyProf, because there is actually I mean, I could probably just remove that. All of this stuff in here is just convenient stuff that I use across async. Some of it I have actually moved into separate gems. Like this one here is async RSpec SSL, and it's just a whole bunch of shared contexts for generating client server SSL certificates. So it can generate a certificate authority, and then it generates. There's actually a couple of contexts. There's a certificate authority which provides a localhost self-signing certificate authority and the related certificate store. Then this one is a valid certificate, so it includes certificate authority context, and then it generates a valid certificate. I'm guessing that one generates host and client certificates, and then those are the relevant contexts, like server context and client context. And I don't know what that's doing. It looks like it's validating it or something. But anyway, so that stuff is just, it's useful for, this one is for generating valid certificates. So I think the certificate is expired. So it's just super useful in any kind of like async IO test that's involving SSL. That's pretty convenient to have all of that stuff just sitting in one central repository rather than ending up having it all over the place, duplicated. Async RSpec profile is just a really simple wrapper that wraps your code in RubyProf, which is actually what's causing the problem. You know, I guess you could argue that maybe that should be a separate gem, but you know, I don't know. Like sometimes you just feel like these auxiliary gems, the gems that are designed to kind of you know, sometimes some of the things should be separate and sometimes they shouldn't be. You know, it's just hard to make that decision sometimes. And this one, async RSpec buffer, it's a little bit stupid. All it does is it makes a file on disk, but it does it in a way so that it's unlinked, so that it doesn't actually exist on the file system. And then you can use it as a buffer. So when you're doing I/O tests and you need to read and write a lot of data, it will basically handle that for you, the buffer and the file and everything. I don't know, like this stuff is just all kind of, it gets used in a lot of different of the async gems, and yeah, I have separated some of it out. Like async memory became RSpec memory, and there's another one somewhere called RSpec files. Yeah, and that one is used in here, RSpec files. Okay, so segfault when running oh yeah, this is a bit of, I really don't know how to describe this issue. I have a gem, async RSpec, which includes a shared context for wrapping a spec in a RubyProf profile However, therefore I'm assuming some change between 0.8.0 and 1.0 has caused some kind of strangely enough, I could only reproduce the issue on Travis, my local computer. That is actually super weird. Here is an example of the test passing. Here is an example of fail with segfault. The only difference pinning gem versions is Ruby Prof or 0.8. Not sure how I can help debug this further, but let me know if there is anything I can do to help. Honestly, this is a pretty weird issue. And it's made more complicated by the fact luckily this is the shittiest bug report ever, but anyway. Okay, this is a weird one. Gem. Looks okay. Someone will come back and so let's pin RubyProf to 0.8.0. Problem solved. Pin rubyprof to 0.8 to avoid seg faults on Ruby. No, 2.4. Seriously, that wasn't really a merge conflict. Weirdest bug ever. Stack Overflow, the cause and solution of all of life's problems. Yeah, it's still broken. What did we do wrong? Why did it only install? What did I do? Oh. That's hilarious. I have no idea what I'm doing. How did I just... Oh, come on. I think one of the more frustrating things is that you have a project where the builds were passing, like, I don't know, in this case 2 months ago the build was fine, and then you come back to it, and the reason why this first failed is because I just updated the readme, and then it's just suddenly, build failed. And of course, like, editing the readme shouldn't cause your build to fail unless you're doing something really wacky in the unit tests. So it's pretty interesting how much something as small as editing a readme can just become like a 2-hour mission. But I think at least we've got to the bottom of it in this case. Hopefully this will pass. Yeah, it's working now. Come on, turn green. Okay, well that was like super boring. If anyone actually watched that, I'm impressed. It was like so unexciting. But you know, you probably learned a little bit async RSpec and why it exists. What else did I have that I wanted to work on? Awesome. It's still going. JRuby and Truffle Ruby. So typical. So this is one of my branches. It's called Thread Selector, and it is. I've been thinking about concurrency and Ruby and how to make Ruby code concurrent without actually changing it, because I think any proposal that takes the form of rewrite your code with new syntax, new keywords, a different language, is just destined to fail, ultimately. It's just, you can't expect people with existing projects that are thousands, tens of thousands, hundreds of thousands of lines of code to rewrite all of that stuff. They will just throw more hardware, more threads, more processors, more RAM, more whatever at the problem, because rewriting it is just too expensive. But the great thing about Ruby is that because it's a dynamic language, we can change all that stuff without throwing all that legacy code away. It's pretty tricky, like it's non-trivial in the Ruby VM to make those changes, but there's no reason why io.read can't do a little bit more magic if it improves concurrency a great deal. So I guess from the point of view that you do encourage users to build something better from the ground up, that's kind of what async is. Async is a gem which kind of shows that it's possible to improve Ruby concurrency. And of course, it doesn't try and reinvent the wheel. It doesn't sort of it's sort of the simplest thing I could come up with that felt like the right solution to improving the concurrency and ultimately the scalability of code. And it can, in theory, like improve the scalability of existing code. There's actually a spec in async that does this. I don't know if it's actually in this one or if it's in async. I think it's in async IO. So in async IO, there is this pretty interesting spec, I think. Okay, here it is. So what this does is there's this module called wrap, which is just defined in the spec because it's just a proof of concept. It's not something I think you should use in real code unless you're super desperate. And all it does is it makes this module called TCP server, and when you call new, if there's a current task, so if async is running basically around the code that you're executing, then it returns async IO TCP server. Otherwise it just returns the normal Ruby TCP server. Same for TCP socket. And basically in this spec, all we do is we include that module into net HTTP, and then we just call net HTTP get response www.google.com. So it's just basically doing that query, and we expect async IO TCP socket to receive new and call the original method. So we're just checking that that it was actually using this class instead of Ruby's native TCP socket. And so what's fascinating about this is that we actually inject this TCP socket into net HTTP and it just works. Like, you don't have to change anything inside net HTTP to make that work. And so in theory, existing code that uses Ruby, I mean, it's all dynamic. All these class names are just dynamically looked up, and it's all duck typing. So as long as you provide the same interface and you meet all the assumptions that are being made, then there's no reason why you can't just throw async primitives into existing code and have it basically just become scalable and concurrent in terms of making lots of fibers and having them context switch more efficiently than, say, threads. Actually, there's been some interesting discussion, the difference between threads and fibers. And I guess in Ruby, because of the global interpreter lock, they're actually not that different, because you can only have one thread running Ruby code at a time, which is pretty much the same as one fiber running at a time. But the big difference is the context switch overhead between thread and fiber. With thread, the context switch overhead is huge compared to fiber. And the overhead in terms of resources, the operating system resources required, is much higher as well. So fibers, they are cheaper to create, they are cheaper to recycle, and they are cheaper to context switch. That's the main performance benefits. So whereas with threads you might be able to say, okay, I'd like 1,000 threads, and that might be realistic on a modern Linux system. You could probably create even 10,000 threads, or maybe even more. But you quickly run into operating system limitations. You simply can't spawn more threads. With fibers, it's completely realistic to make tens of thousands, hundreds of thousands, even millions or tens of millions. In Ruby, it's not quite realistic because the garbage collector overhead starts to become like a real big factor. The Ruby garbage collector, every fiber has its own stack, and the GC is ON, where N is the number of stacks. It doesn't matter if the stack is in use or not, or has changed, or is there is just no way to, with the current design of the Ruby GC, to avoid that stack sweep. So when you have 1 million fibers, the GC just gets overloaded with stacks. I've discussed that with Koichi. I'm not really sure. There might be a solution to it with Ruby. Of course, in other languages where you have more structured GC, you can avoid some of those issues. So it's not intrinsic to this approach. It's just kind of an artifact of how Ruby works, which is unfortunate, and maybe it can be worked around or maybe not. But to be honest, even in a modern web server, hundreds of thousands of fibers per second is actually perfectly acceptable. Getting to millions per second would be really awesome, but tens of thousands to hundreds of thousands per second is pretty good at the moment anyway. So thread selector. So coming back to that, I've been thinking a lot about how to improve improve Ruby IO to the point where we can make Ruby programs more concurrent. Now, I'm pretty strict with my definitions. I consider the words concurrent and parallel to be quite different terms. Concurrency means time sharing. So what that means is if you have a processor and that processor is basically every second, it might be split into 100 millisecond quantums. So you have 10 slots every second, so you can run 10 different processes. And that's concurrency when you schedule process A followed by process B followed by process C, and that's what fibers are. Fibers are concurrent. Threads, on the other hand, while threads can run concurrently, they can also run in parallel, which means if you have multiple processes, they run at the same time. And it's different from concurrency. Parallelism is when you're running these things at the same time. Concurrency is when you're slicing them and putting them one after the other. And of course, you can look at those different things, and you can say, well, it's possible for threads to run concurrently, and it's also possible for threads to run in parallel. People who say fibers can run in parallel, like Crystal has this very strange definition of fibers that it can run on different threads or switch, like move between. I don't know if it can move them between threads, but it can definitely spawn them on different threads. Fibers, in my mind, that means a unit of computation that sits on one thread. So you have processors which have threads and threads which have fibers. And fibers don't go between threads. There's something different. So when you call read, read and write are the biggest sources of latency in the majority of Ruby network programs like web servers, WebSockets, that kind of stuff. There are a couple of other sources of latency. Another really big one is file system operations, like reading and writing files from the hard drive, although SSDs are getting pretty quick. And some of those latency is hard to avoid because if you use something like memmap and you map a file into memory, when you dereference a pointer, you are essentially causing a page fault, which then causes the operating system to yield your process until the storage device can page in from disk into that page in memory. And then once that happens, then you can resume reading from that pointer. So some of those operations aren't gated by system calls, they're just page faults. So there's a lot of different levels of non-blocking operations, but read and write are pretty much one of the biggest sources of latency. And so what I want to do with Ruby is I want to try and make it possible for read and write, the native like io.read and io.write, to yield if the operation would block. And the way that yield should work should be controlled by the user. So the point is you wrap your code in a fiber and you have a selector per thread. So essentially a thread runs a selector, you set up a bunch of fibers which are doing I/O, and that selector will concurrently switch between those fibers. And that describes 99% of server software. So if we can nail that with both a scalable if we can get both concurrency and parallelism. So what I mean by that is you might run 8 processes, and each process has one thread running a selector which is servicing 10,000 fibers per second. That would give you 80,000 requests per second. So if we can nail that for Ruby, I think it will be really good, because performance isn't all about how fast you execute CPU instructions. It's actually about how you deal with latency, inherent latency in your program. So database queries can be a big source of latency as well, and you need a way of dealing with that. And every database API has its own magic snowflake to deal with concurrency. So, what am I doing here? I have in this branch I've made a bunch of changes, and unfortunately the test is now broken because someone, Eric, I'll blame Eric, because actually it was his, it wasn't, it's not a fault, but he made the changes that broke my code. So there are these functions in Ruby: RB, IO, wait readable, and RB, IO, wait writable. And also RBF sleep, and there's actually a couple of other ones, like a couple of entry points I need to handle now as well, but those 3 points were basically the main ones for dealing with non-blocking IO. So if you call IO read, let's say 1 megabyte, and Ruby asks the operating system for 1 megabyte and it gets back 300 Ks, and then it asks for another for the remainder 700 Ks, and the operating system says, sorry, I don't have the data right now, so the operation would block. Then Ruby will call RB IO wait readable, and all I did was add like 1, 2, 3, 4, 5, 6. Let's just ignore that one. It's 4 or 5 lines of code, which basically look up this thing called the current thread selector, and if it's not nil, then it calls wait readable, or wait writable, or wait sleep on that object. And then essentially that allows you to supply user code to hook into the non-blocking infrastructure within Ruby. So I think it's pretty cool because it's like a really simple solution which basically allows you to make Ruby non-blocking. And I think it's kind of future-proof because if we change, it doesn't make any assumptions about the implementation of those functions. So if you choose to use event machine or async, or you shouldn't use cellular IO, but you might be because it's a legacy code base or something, and you want to make as much of Ruby non-blocking within your event loop. So like in the case of event machine, I assume there's some way in event machine just to say wait for this file descriptor to become readable or writable or something. Then you just hook into this, and then NetHTTP, NetSMTP, Faraday, REST client, like anything that just basically uses native Ruby IO just becomes concurrent within the scope of a fiber. So I think it's a pretty cool solution, but let's it's broken, so we're going to fix it. So let's actually have a look what's going on. So I have my build directory, and I don't know if I have actually a test harness set up or not. So there's this file called test.rb. I don't know how much progress we'll make on this tonight, but we'll have a look at it. Run Ruby. I think that's what I want. So that builds Ruby, like the current branch that I've got, which has my 4-line times 3 patch. And then it will run this code using that Ruby. And this code, it's a selector, and in theory it has those 3 methods: wait readable, wait writable, and wait sleep. And it just implements that using fibers and io.select. And I guess you could obviously implement this yourself. Like, I mean, MRI, the core team, could implement this in C and avoid the GVL traversing from the C code back into Ruby. through those callbacks. I mean, there's a ton of ways you could do it, but I guess in my mind it's just a proof of concept. So I upgraded my GPU, but I think I should upgrade my CPU next. The Ryzen, like what is it, 12 or 16 core CPUs, they look really amazing. How many cores do they have? What is it, the 3900X or something? I could build 24 files at a time. That would be pretty epic. Yeah, I think my current CPU is a bit ancient. What is it? 4770. It's not that bad. How many years old is that? When was it released? Oh, there we go. 2013. Anyway. So this test, it makes a new thread, and then it makes a new instance of this selector code. Let's just make that a bit less. Let's just, I don't care about any of that stuff. And then it makes a new fiber, and inside the fiber it calls sleep I. So 5 times do sleep I. I actually don't know where it is printing out that number from. I think I had it before and I deleted it. Okay, good. Right. That seemed very fast. Okay, my bad. I was reading the code wrong. Well, I was reading it correctly and understanding it wrong. It's making 5 fibers, and each fiber sleeps for a different amount of time. So of course, all the output comes at the start, and then if we actually want to see a staggered output, we should do that. Right, so how does this work? When you call sleep, which is actually kernel sleep, I think that should just work the same way. Sleep is implemented by this function rbf sleep. Right. So in RBF sleep, so this is the kernel sleep function, and it gets the current thread selector. If it's not null, then it calls wait sleep and it returns. So it doesn't do the normal pathway for sleep. And I guess if you were really stupid and you just called sleep inside this function, you end up in an infinite loop. But that's not the intended use case. So what happens is we call wait sleep. So the implementation of wait sleep, there's this waiting hash table keyed by the current fiber, current time plus duration, and then we call fiber.yield. When you call fiber.yield, what's actually happening here is this whole fiber we call kernel sleep, which ends up calling this line here, and that causes it to exit out of this regime, which makes the loop go 5 times. And then finally it comes down to selector.run. So the magic all happens in selector.run. While there is something that's waiting, we call io.select. Now there's no io, so that's just going to be empty array, empty array, empty array, and then the next timeout. And next timeout, this was just a quick hack. It's not efficient by any means. We have the hash table of fibers that are waiting, and we sort them by the value, which is when they're due to be resumed, like when they're due to be expired, and we get the first one. And if that timeout is, if there was something waiting, we compute the offset by looking at when it was supposed to time out and minus the current time. And if the offset was less than 0, then we should io.select should not have any timeout, like it should just return right away if nothing is readable or writable. Otherwise we return that offset. What that means is io.select will wait for that amount of time for any of those readable or writable IOs to become ready. And if they don't become ready in that timeout, then it will return. Those will both be empty arrays, and it will come down to this part, which will basically resume anything that's waiting where the timer is less than the current time. So basically has expired, like the sleep statement has completed in terms of time passing, and it will call fiber.resume. And so fiber.resume will come back out here. It will jump straight from here into this code, has obviously changed back into that fiber, and then it will return from here, and then it will print out that it slept for however long. And that's it. That's really the whole implementation. It's not really any more complicated than that. So that spec, this is a spec which implements and it tests read and it tests sleep, and this one is failing. It used to pass and now it's failing, and it's failing because Eric changed how things work in io.c. In io.c, there is rb io readable. It takes a file descriptor, and its job is to call rb thread wait file descriptor. And I actually don't know how that works. I assume it has some non-blocking implementation, but it has changed. And we have these internal read func and internal write func. And the reason why these exist is because of how Ruby does exception handling. And in this case, when you call RB write internal file descriptor buffer and size, it creates a struct which stores those arguments, and then it calls RB thread IO blocking region internal write func, that struct that contains the arguments, and for some reason the file descriptor, I actually don't know why it needs that. Maybe it's for logging or something, I don't know. Yeah, so that function, that will probably release the GVL, call that function with that argument, and then when that function returns, it will regain the GVL and come back out here. So it's basically we have to wrap it up. And I don't know, like, I guess there's other ways of doing that, but in C it's just that's the way you do it in C. So it doesn't call RB IO wait readable or wait writable anymore. These functions actually work independently of that machinery. And I'm not sure I agree with that change. Like, I understand what Eric was trying to do. He was trying to make a central kind of funnel for that stuff. But in the end, we just kind of ended up with the original wait readable and wait writable was it's still there. It still works independently of this other code, which implements largely the same thing. So how this works is we have internal read function which calls read, and if the read would block, it calls no GVL underscore wait for single file descriptor. So that is another entry point which with a thread selector would need to invoke the user code. So we need to reacquire the GVL and then call the user's code. And that's what I wanted to work on. Honestly, I don't know if it's a good solution how this is structured now, but I'm not so interested in why it's or how it's structured. I just want to do the proof of concept that shows that hitting the user code can work. You know, you can build a concurrent system by providing your own custom per thread selector. So okay, I'm just going to take a 5-minute break and I'll come back. Okay. So basically what we need to do is, in this code, no GVL wait for single FD, we need to call back out if there's a selector defined. So cut and paste. Now, because it is this function, most user code either is writing from a file descriptor, writing to a file descriptor or reading from a file descriptor. You don't often have code that somehow executes both those operations in parallel. You could have two separate fibers, one is reading and one is writing, but they're separate operations. This function, it mixes them both together. Like you end up with basically events can be reading, writing, or both. And so the reason why this could be both, actually in this case, I don't ever believe it's possible for this function to be called events both readable and writable in normal code from the Ruby point of view. But in async, when you have an IO wrapper and one fiber calls read and another fiber calls write, down in the guts of the event loop, you'll end up with events being both read and write, and that will bubble back up through the event loop to those specific fibers depending on whether it became readable or writable. So it's not really feasible for us to call wait readable. I guess we could look at events, and if it was reading, then we could call wait readable, and if it was writable, we could call wait writable. But actually I have this function here called wait for single file descriptor, and so we'll just use that because I'm okay with that. Like it is what it is, and we have one argument, and it's the file descriptor. Now, events and duration. I actually don't know what that is going to end up looking like, and duration is no because we don't have that. And I'm just gonna slap that in there. I just want to try and make this work, and then I'll make it beautiful. I don't know if RB fun call will reacquire the GVL if it's not. Yeah, I just don't know how that works. It might just crash, but that's okay. I'm not worried about it crashing at the moment. Where did this one? I just want to grab. I want to grab that test code. Actually, I already have all of that stuff. Let's just grab that bit. So Eric had a pretty good idea to make all I/O in Ruby non-blocking. It doesn't actually. It's not what it sounds like. All I/O in Ruby. When you call io.read and give it a length, it will loop until it gets that many bytes of data, or the I/O is closed. So all I/O in Ruby in a way is blocking, and when you make it non-blocking, it's sort of confusing, but Ruby will implement its own polling or select within that loop rather than just calling read and using a blocking read in the operating system. When you make an I/O non-blocking in the sense of IO/non-block, like in this sample of code right here, it's basically just telling Ruby to use select or poll in its loop rather than using read and just calling read over and over again until it gets the data that it needs. It's pretty confusing because it doesn't change anything. Like, it doesn't change any use of it. Like, you set this and you think, oh, it's going to make all IO non-blocking, and nothing changes, and you're like, well, what did that do? And I was super confused when I first did that. Didn't make any sense to me either. I don't know why I'm doing it 5 times. I really couldn't care less. Let's just do it once. Okay, right. So make a thread, make a selector, assign selector to thread current selector. We make a pipe. We make the pipe non-blocking. I don't even know if that's needed anymore. So Eric's patch was to try and make that the default, but on Windows, of course, nothing works the same way as anything else. So that was a bit of a nightmare, apparently. We made 2 fibers. The first fiber calls on the input end of the pipe read 20 bytes, and on the output end of the pipe, in a different fib, we write data and we close the pipe. So in theory, like, the flow of logic in this program is it comes in here, it creates a fiber, it calls i.read. I.read, the data is obviously not there yet, so it will call wait for single file descriptor with the file descriptor. The event should be like readable. Duration will be nil in this case, and like something should go. There's no code in here, so it's not going to work at all. But it will print out this line. It should print out some message. Assuming that function does what it's supposed to do, this will yield. It will come out of here and it will run the next fiber, which is going to write data to the pipe. That write, because that is 11 bytes of data, that will just go straight to the operating system. That will never block unless something is incredibly wrong in your operating system. And then it closes the output end of the pipe, and so then that read operation will just read that whole message in one go. It becomes readable, of course. It resumes back into this point, reads, completes, the message will be hello world, and then it closes the input into the pipe. I guess what we could do is we could just print out the message. So I am pretty sure that this is going to break, but let's see what happens. Okay, that was easy. Okay, number of arguments. My bad. Undefined method non-block equals. I know. It's such a weird feature that it's not even there by default. So, okay, something worked. Something happened. Wait for single file descriptor. So it just got, because the data was never there and it didn't ever yield, so the fiber couldn't start. It just went, became infinite loop. So if events and 1, I assume that it means wait readable. I don't know what. I guess is it documented in here? Poll in and poll out. RB wait FD in. Where is that defined? Yeah, it's not defined anywhere. That's helpful. Awesome. Indented preprocessor statements. Oh, goodness me. It's just something totally random. You know what? Maybe it is just simpler if I call wait readable or wait writable, because otherwise I have to expose to the Ruby code. Okay, let's just make this static value. Wait for single FD. I'm just thinking about where this is going to end up if I write this code. I'm not really sure I like the direction it's going in. You know what? For proof of concept stuff, I'm just gonna hack it in. I don't even know if that's right. Okay, it looked like it made some progress. We called that. That eventually happened. What am I need to return, probably need to return true. Oh no. Okay, good. What is this supposed to return? Is it ever returning? I don't know why this is completely trashing the VM, but it is. Okay, so it is returning. The aspect of it is good. I wonder if I'm not handling the GVL correctly. I wonder how that works. Does RB function call acquire the GVL and then not release it? I just don't know enough about how this stuff works. If it doesn't equal -1, go to retry. I am returning our test result. What the hell is it doing? I'm pretty sure our test is just a macro that turns a Ruby value into either 1 or 0. Basically the same as an if statement in Ruby. So it can never return -1 actually, I don't think. But something strange is happening. Hey, let's just print out what's happening in here. Actually, I guess I could just use strace. It might be easier. Actually, you know what? Strace is not going to be very easy. Can I just run that? Okay. Mini Ruby. It's running test. I want to use strace and I want to print out file related system calls. Hey Robert. It's not morning, it's nighttime for me. It's like the perfect time for programming. Strace can print out system calls, but I don't remember how to make it work. Dash E trace. I just want maybe that one. Let's try that. I think that might work. Okay, let's. I don't know. I think it's gonna work, but maybe. Oh, there we go. Oh, it did work. That's good. That did not give me the system calls I was hoping for. Wait for single file descriptor 5. I think I need to make sure strace follows children dash F. Codish. No, this is very annoying. Okay, that's more like it. So it was spawning a child process. Okay, so I.read. It tried to read 20 bytes and it returned -1, which is E again. So it basically hit that code path. Let me just make that bigger. And so then of course that calls no GVL wait for single file descriptor. Ah, there we go. So the final read call did actually work. So why is it not coming back out in the Ruby code? I reckon the GVL is just foobar at that point. I reckon I'm stuffing up the GVL. I think it's Ruby fun call is acquiring the GVL. I don't know anything about the GVL. How do I print out if the GVL is locked or not? I don't even know how to do that. GVL. Okay, here we go. Ruby thread has GVL. How does that work? What does it do? Oh yeah. So how do we release the GVL? RB thread call with GVL. Okay, I guess I'm just gonna have to do this. I'm gonna have to go all in because I reckon that's what's causing the problem. I think I'm just completely foobarring the Ruby virtual machine. Okay, so takes a function which takes one argument, void pointer, returns a void pointer which gets passed back out, and that struct obviously gets passed straight through. This is all a bit of a giant hack, but it's okay. I guess I could make a struct. So we make this struct which has the args, and then we pass it through as a pointer to this thing called rb_thread, call it GVL. rb_thread selector wait for single fast, we can call that function with the args, invokes the user code. I gotta pass in the freaking selector. Since we have it already, can we return a value in a void pointer? I don't think so. I don't know how we can do this. Just seems like a giant hack, but it is what it is. Alright, that might work. Might. I'm not very confident in this code, but that's okay. Get the current select. If it's not nil, we make the args, which contains everything. rb_thread call GVL, because we don't have the GVL, we call that function. In theory, that should invoke the user code. Comes back out and works. Yeah, maybe. I don't know. Let's see. Okay. Okay, semicolon. That was the first mistake. Result in something's not. Okay, right, yeah. And it's a pointer. Should have realized that. You can tell I write C a lot. I find context switching between languages, it's pretty funny. Sometimes you just end up writing the wrong. You start writing. A long time ago, I used to write PHP in a past life, and I used to end up writing Ruby and PHP would just get mixed up, and yeah, it's pretty easy when you write about 100 million different languages. Oh, it worked. That's good news. So it was the GVL. So it does need this. I don't know, look at this code, I think, what a god-awful mess that is. I mean, what a spaghetti monster awful mess that is. But, I don't know. Don't have the solution to making code, it is what it is. It's pretty frustrating that it can't just... C is very explicit and very basic. Sorry, I'm just drinking my tea. It's cold now, though. It's jasmine tea from RubyConf Taiwan. They have amazing tea. It's all really awesome. So, I hate copying and pasting that, but I should really set the tab size correctly. So yeah, I think that now my test should pass. I hope. This one. It tests the sleep functionality and the IO functionality. So let's try and see what happens. Okay, make... Why can I not type in that terminal? Okay, there we go, that was weird. Make test all tests equals... I don't know if that works or not. Koichi told me how to do it. I just always forget how the Ruby Makefile works. So many different... I think over like 10 years, everyone has just added different options to that Makefile. It's just a monster. And the hell? I was trying to autocomplete. Awesome. What the hell is the test name? It's good test. Why is that not? No, I don't want to delete those files. Oh god. File not found. Hold on, I'm just gonna look at what Koichi told me to do. Give me 2 seconds. Okay, I almost had it, but not quite. Okay, there we go. It's obviously working. What happened there? Oh, I think I know what happened there. This code is, the implementation is empty. I need to copy this unbelievably awesome, completely functional implementation. It's not. It's actually very broken because if events was readable or writable, it would break. But let's just ignore that for now because the test will pass, I think. Time interval must not be negative. I thought I was hold on. You know what, I should just copy this whole implementation because it's different. It's changed. Stuff has changed. Missing those. Yeah, awesome. Okay, all the tests passed. Fantastic. Okay, let's remove. I feel like I should probably implement this correctly. It gets even more tricky if you have multiple fibers calling read on the same file descriptor, because it's not even obvious what that should do. If you have two fibers and they both call, like, say, read 10 on a network socket, and the first read call gives 5 bytes, so that fiber goes to sleep waiting for more data, and then the next one wakes up out of order, reads 5 bytes. There's no sequencing to it, so they'd both just end up with the wrong data, or they end up with like 5 bytes completely out of order, and then you might end up you just end up with corrupt. I guess the data you'd have to make sense of it, but it wouldn't make sense because it would just be out of order. So we're in a tricky situation because in theory someone could call wait readable from two different fibers with the same file descriptor, and we would basically we would trash if there was a previous entry in that hash table for that particular IO. And we don't check for that, which is okay because this is just a proof of concept. Async IO does, and it will I can't actually remember how it works actually. Let's have a quick look because it's kind of interesting. I can't remember if the core of the code is an async or async IO. I think it's an async. So this is the IO wrapper class. It basically wraps an IO and binds it to a reactor. And it has wait readable, wait writable, wait any, and it basically internally maps that into NAO for ours, reactor, register, and handles all of that for you. So wait readable. Right, so if you call wait readable from two different fibers, if a fiber is already waiting, it will raise a wait error. I think that's the correct logic, because trying to read or write at the same time to the same file descriptor is just doesn't make sense really. I can't think of any situation where that makes sense. At least in the context of socket streams. Maybe like in UDP, it makes sense. No, because having one thread with two fibers waiting on the same socket for packets just doesn't make sense. It's a race condition, which one would wake up first. You'd be better off having one fiber reading packets and then putting it into a queue and having other threads or fibers or something else pulling them off the queue. Yeah, I don't know. It doesn't really make sense. Anyway, so we just ignore that. I guess we could, in here, we could throw an exception if it's already, someone is already waiting or for it or whatever. But yeah, I don't know how Ruby handles it. Like if you made two threads and you called like file.read or something, or socket.read on the same socket, I don't know what Ruby would do. Probably be pretty interesting to figure that out. Right, so we make an IO. So if it's readable, so if it's readable, we put it in the readable table. If it's writable, we put it in the writable table. And then we call fiber.yield. Now, I guess my next question... Yeah, we have to delete it. Let's just copy that bit of code there. That's interesting. I actually changed the implementation slowly. This implementation is using fiber.transfer. Okay. We just delete it from both. I don't care about checking that. The C code is probably faster than doing... I guess the only case you could do is you could rewrite those two conditions afterwards and only put delete. But I just don't care enough to do that. So, again, like proof of concept. Am I looking at the right terminal? Yeah. Hey, awesome. I wish that could be more robust. Even though it's a proof of concept, that annoys me that I'm just randomly using those constants. It's obvious what it is. Okay. I don't really care much about that. It was just... Sometimes when I don't know how things should be designed, I just make a file and I start writing code that doesn't make any sense into it. Just to try and... Like an artist, like sketching out a black and white pencil sketch before you start painting. Sometimes I just feel with code like the same thing makes sense. Because you really, I don't... Maybe some people know what the code is supposed to look like before they start writing it, but I just think it's good to... It's like Lego blocks. You can build things a million different ways, and there's no criteria. No one way is necessarily better than another way. It's just different. You don't necessarily know how they're going to work out until you actually do it. What the hell is this? Threads.reveal. It's just old code. I don't care about that. Okay. I think we have fixed this branch. What's wrong with the indentation? Ah, it literally is the wrong indentation. It's okay. The last commit was just something totally random, so let's just tidy that stuff up. It's not a regex. Come on. Add support for no GVL, wait for single FD to thread selector. Now I should actually tidy up that code too. Yeah, I think we're good. There was already a pull request for this, but it was just closed as part of general maintenance. Thread selector, that one. Can I just reopen it? The thread selector branch was force pushed or recreated, so I kind of just... Why does that matter? So if it's that one, I can reopen the pair, and then I can force push. I just don't get it. Okay. Okay, hit it one. Come on, GitHub, you can do it. Excellent. Okay. I don't think Eric is on GitHub, unfortunately. I'm happy with it as a proof of concept, however, I think we need to revisit Eric's changes because we now have it's not the greatest. Here's proof concept. In addition, added support fucking into kernel sleep. Well, my use case is primarily set. Eric's code path, which avoids the GVL, would benefit from staying in C directly to the event loop if possible. Me think about having a generic rather than using RB fun call. So what I've been thinking is, well, my use case, async is pure Ruby, except NIOFR, and NIOFR releases the GVL when it goes into the event loop. So the way that works is, let's just go there. There's a wee bit of voodoo black magic inside the libev code, which we hack. In EV run, this is the event loop. Somewhere in here, we use that same function again, RB thread call without GVL. That basically releases the GVL when libev invokes its own non-blocking event loop, like poll select, KQ, epoll, and so on. So in theory, if you could enter this function directly from that no GVL, wait for single file descriptor, then you wouldn't have to do that, and you would avoid contention. You'd avoid contention. I don't know how much contention you'd avoid. I don't know how expensive it is to jump through RB fun call and then for that to jump back. Yeah, I don't know. I don't know how much contention you'd avoid. Eric's code did make me think that maybe we should provide hooks to avoid that contention, although they wouldn't personally be that useful to me with the async code path. But I don't know. Maybe I just won't talk about that. Okay. There are two things which I think we should consider. Thing number one, whether we should explore this concept further. The proof of concept works, but I'm open to feedback and ideas. Whether we need to refactor Eric's changes, given that the auto fiber branch he was working on is almost certainly, I don't call it dead, but I don't think he's going to complete it. Given that he's no longer working on it, we have part of his, some parts of his work were merged, which is great, but they are in isolation to how things worked previously and stand on their own. So we I think I'm good with that. I don't really know. I guess my goal is to get people involved, but everyone's busy, and not, unless you have time to drive it yourself, it's hard to pull other people on board. Well, I have to say, like JRuby and Truffle Ruby have been really, they've been really passionate about trying to support fibers correctly, which has been really awesome. The status of async on Truffle Ruby, I think, is pretty good. Or maybe it's JRuby. I don't know. I get confused. Let's have a quick look at this builds. Could even be both of them now, I don't know. Truffle Ruby is all passing. It's pretty damn impressive. The async test suite is pretty thorough on the behavior, like if the test suite of async is passing it, it's a pretty good indication that everything is going to work. Which one is... This can take a while. Running all the tests can take ages. How can I see it? I don't know how any of this stuff works. GitHub Actions. Everyone, here we go. Finally pop. No, but I want this one. I have no idea why that's not. Why I can't just see what it's doing. It's done something for 4 minutes and I can't. Anyway, look, I think that's it for today. If you're interested in the thread selector patch and changes, look, the best thing you can do to help out is just you've seen the code, you've seen how it fits together. I think really the next step is to it's really to see how we go from having, so that this selector implementation is super basic, and what would be interesting is to fit NIO for into this, and there's an open issue. I just threw it out there because it needs to happen eventually. So it'd be pretty interesting if inside the NIO for our gem we could make an implementation of a compatible selector, which then you can throw into thread.current.selector and just have NIO handle that. And there's actually a corresponding issue on Event Machine as well. I don't even know if that's the right org. Oh, yeah, it is. So there's been some interest, like obviously I mean, this guy has obviously been working on Event Machine for a long time. So if he's excited about it, it's a good sign, I think. And so yeah, there's those two issues. I think it's really about connecting the dots now. If we could connect thread selector with an event loop, like a real event loop, like Event Machine, or for and I think it's also a matter of looking at what other hooks might be required. I mean, in my mind, blocking operations are okay. It's just you look at the hierarchy of which operations are blocking and how badly how much latency they're introducing, and waiting for readable and waiting for writable, and sleep. If sleep is like big, it's introducing a lot of latency. But of course, you have things like name resolution, like DNS name resolution. Some other ones would be things like reading from the file system. Even like enumerating directories in a file system can be a slow operation. libuv has a big surface area because it tries to provide all of this stuff. Asynchronous TCP and UDP, asynchronous DNS, asynchronous file and file system operations, file system events. It sounds pretty cool. ANSI escape code controlled TTY. It sounds pretty interesting. IPC with sockets, child processes. That means you can do things like process.wait, but it's also asynchronous. Like process.wait would hit your selector with something like wait child process or something with a process ID, and so then you'd feed it into your own event loop and handle that correctly. Signal handling is another one that's quite tricky to get right in the context of a concurrent system, and the other stuff, who cares about that? It's probably all important. So it'll be interesting to look at. We have this really amazing ecosystem of event loops things like libuv, which just provide everything all the way down to NIO for R, which provides very basic IO, like non-blocking IO event loop. And it would be cool if we could just, slot those into Ruby, depending on your requirements. So if you needed, like if all you needed was non-blocking IO, then NIO for R is perfect. But if you needed like non-blocking file system operations and non-blocking DNS and non-blocking all of that stuff, then you could install a gem called libuv or something, and then go thread.current.selector equals libuv selector.new, and you would just make Ruby do all of that stuff completely asynchronously. Yeah, of course it's more complicated than that, but that's really the next step, I guess. Like that's where it goes to from here. That's where this ship is sailing. This direction we're going in. So getting involved and getting excited and thinking about how to do that stuff. That would be awesome. Okay, before I go, I want to see if any of those builds passed. That'd be pretty epic. Blew up on Mac OS. Oh, but it passed on Ubuntu. That's cool. That's awesome. No one cares about Mac OS. Okay, look, I think that's it for today. I'm going to try and do this every weekend. It might not be so complicated. This was like 4.5 hours of coding. My goal is, I've been thinking about different formats, like having like a QA style format where people just come into the channel and say, hey, how do we make the following code asynchronous? Or even things like I've been, like problem solving. If they've been trying to implement, like, people come to me with like, oh, how do I do this? I've written this code, and how do we make it asynchronous, or why is it not working? So I think, think about if you have like things like that you're interested in. I'll try and do this again next weekend. So if you have something, just feel free to make an issue or something and say, can we chat about this, or can we do a live coding session on this particular topic? So just throw it into one of my Git repos, and I think we just go from there. That'll be awesome. Excellent. Thank you very much, everyone. Have a good night or good morning or whatever it is, wherever you are.